All right, final assembly. We'll just snug that down and... Guess I need to change the dimensions on that. Hello, Internet. My name is Quinn, and this is Blondihacks. I'm finishing up the lottery wheel, raffle wheel, spinny wheel thing this week. I still don't really know what these are called, but you know what it is, and we're going to get to see it actually spin this week. This should be really fun. I think you'll enjoy it. Let's go. When last we left this raffle wheel, it was looking very spinny. So far, so good. But we need a stand, of course, and some other paraphernalia to make it into an actual raffle wheel. We were kind of in the middle of making the stand last time, you might recall. I have the main plate cut out, and we'd done the bore for the bearing. I don't want to actually push that bearing in yet, however. We've got much more to do before we get to that stage. I don't want to press this bearing in and out more times than I have to, and there's going to be more finishing and so on before this final step. That backstop is all well and good, but we're going to need a base as well, so I cut another square out of that scrap material that you've seen on this project. And this stuff is nice and flat, but it does have this giant manufacturer's sticker on it, so a little bit of heat made short work of that. Pro tip for life in general, there's no adhesive that can stand up to heat, so when in doubt, get out the heat gun. This is kind of what I have in mind. I want the stand at a slight angle so that it's comfortable to use when the wheel is sitting on a desk for someone of sort of average height. Not too much of an angle so that kids can also use it, but that's kind of what I'm thinking. I need some kind of a hinge though along the bottom because I want this thing to fold up. If it's not foldable, then it's going to take up a lot of space and it's going to be awkward to transport and store. I think I can make a pretty decent hinge out of some scraps of round bar that I found in the bin. One of my primary goals for this project is to minimize part count. I want to build a foldable raffle wheel with as few components as possible, partly because I do have somewhat of a time pressure on this, but also just because I want to make this thing as simple as possible and still functional. I turned down one end of this round bar so I can put some threads on it. Toward that goal of minimizing part count, I tried to come up with the simplest possible hinge. Hinges are inherently high component count. There's a lot of little fiddly bits you have to make. But I decided if I make a couple of bushings out of this larger diameter stock, then I can thread one of them and thread the hinge pin into one and leave the others with a clearance bore, and I should be able to have like a self-retaining hinge pin and hopefully fairly minimal number of pieces. You'll see how it all comes together. But using this slightly larger diameter stock, I turned down a bushing and then tapped a thread into the middle of this one. The actual size doesn't matter a whole lot. I'm not being super accurate here, just kind of winging it with the stock that I have on hand. The thread I chose was just one that had a major diameter that matched the round bar pretty closely, so I didn't have to do a lot of diameter changing there. Again, just trying to do this as efficiently as possible. So we'll Yahtzee that off of there. Now, each hinge, there's two hinges on this whole assembly. Each hinge consists of one threaded bushing and two or more unthreaded ones. So I made those as well, all in one setup here. I'm not going to bother showing you machining a whole bunch of bushings. You've seen me make bushings on this channel. Here's how it all goes together. The threaded bushing goes in the end of the rod, and that's what retains the hinge pin in the whole assembly. And then the unthreaded bushings go on over top. There's 3 of those. So 2 of those get attached to the moving part, and the other 2 get attached to the stationary part. And the whole hinge assembly ends up only having 5 components. I think that might just be crazy enough to work. To make that hinge pin then, I'm going to have to cut it off to length, so I marked that. And what I actually did is I ran the end of it into my bandsaw blade to create a screwdriver slot. And this is going to sit flush with the outside hinge pin. Again, reducing the need for a nut or a hex profile on the end of that or any additional components. Just a simple screwdriver slot and one less component to make. Time to attach those hinge pieces now, so over to my little welding area. I'm going to set this up in such a way that the hinge barrel is kind of in the middle of the moving part so that it'll have freedom to move and lie down fairly flat. So I've spaced it up with the base plate. I'm going to get everything in position, and I'm using the hinge pin in there to keep the barrel pieces in alignment while I do this. Of course, things tend to move while you're welding, and I want to hopefully minimize that. I also don't want to put too much heat into anything which would cause things to warp and cause the hinge pin to no longer slide in and out or pivot smoothly. So I'm just putting small tacks on each of these hinge barrel pieces. As I said before, the 2 inner barrels get welded to the moving part, and then the 2 outer barrels get welded to the base plate, thus forming the hinge. After putting tacks on one side of those inner barrels, I made sure that everything was still moving smoothly. The hinge pin still pivots, so nothing bent or warped. That's good. Then I flipped it over and I put a tack on the far side as well, just to add a little bit more strength and also make sure that things stay in alignment. So far so good, that seems to be working. So I think my overall approach is not crazy, so let's proceed. Then I line up the hinge plate on the base, getting it centered and kind of roughly where I want. I want a little bit of a foot on the front for stability so that kids can't pull it down on top of themselves, which of course would be bad. This thing will be heavy. And then I weld those hinge barrels in place on the base plate. Once again, I have the hinge pin in place to hold everything in alignment while I do this. One thing that would have been a good idea was some anti-spatter spray before doing this, because then when I did the first test of the hinge, things were a little sticky because there was weld spatter in between the barrels and the plate at the bottom. So I kind of scratched up the hinge barrels pretty badly the first time I opened it because there was weld spatter on everything. Live and learn. But I did the same tack on the other side of those other hinge barrels as well. I cleaned up all the spatter and kind of buffed up the hinge pins a little bit to remove the worst of the scratches, and it's now moving extremely freely, so that actually is working really well. Better than I'd hoped, honestly. I kind of expected everything might move a little bit while I was welding, but it really didn't, and that hinge moves really, really beautifully. So for 5 trivial components, I'm pretty happy with that as a hinge. If you've got a lower component count hinge, I'd be interested to hear it, because it's one of those components that I'd like to make more of, but it's such a hassle because they have so many parts. I suppose you could just use a gate hinge or something from the hardware store too, but then it looks like you used a gate hinge from the hardware store. After verifying that I can pull the hinge in and out, then I can move on. One of the key design goals here is everything has to be take-apartable. That's not a word. Because I want to do powder coating on all these parts, which means I have to be able to disassemble and reassemble them all non-destructively. That goal is somewhat at odds with lowering part count, because to make things assemblable and disassemblable, you always end up having to add fasteners and things. Now I have to set the angle for the back. I just kind of picked something that looked good, because I'm going to need some sort of like a kickstand on the back to hold it up. I've got this piece of scrap here that's a little rusty, but perfectly good after some cleanup. This was actually donated to the channel by my neighbor. I have a neighbor who is a farmer, and farmers have lots of steel lying around, and he donated a bunch of it to me. It's perfectly good stuff, and I'm happy to give it new life. I made another one of those hinges of the same design, this one much smaller and only using 3 barrel parts, 1 threaded, 2 unthreaded, but otherwise the same design as the big hinge, and this will hinge the kickstand on the top. That one also seemed to go well. The hinge pin still comes in and out, and the hinge moves smoothly, so I believe that is a result. So far, so good. Now, we need something to kind of hold the kickstand in position, and this is actually an important safety thing, because I don't want little kiddos to be reefing on it and have the whole thing collapse. I started by marking and welding a little backstop, because I know the kickstand is going to at least need that so that it doesn't slide backwards past where I want it to sit. I'm kind of making this up as I go along. Well, not kind of. I'm literally making this up as I go along. I had no plan for this whole project. That looks like that's pretty good. Now, of course, that doesn't prevent anything from pulling forward on it. So if you grab this Raffle wheel and pull down on it, the whole thing's going to flop forward and collapse. So I need something to retain it vertically. So I thought, well, maybe I could drill a hole in the bottom of that kickstand and run a pin through it. And that would lock everything together. So a little bit of quick work on the float lock vise, and that gives me a hole. Let's set that up once again and see how I can maybe put a pin in there. It looks like I can take an offcut from one of the hinge pins and weld it to the top of my little backstop, and that seems like that's actually going to hold it super securely. Again, just making this up as I go along. I had no idea if that idea was going to work, but it looks like it did, and the whole thing will still fold up. So I'll set that all up in position kind of where I want it, and I welded the pin down to the little backstop. And honestly, that worked better than I could have possibly hoped for. That was, again, my first idea, random idea, but that actually seems to work super well. It's easy to clip into place, and once it's clipped in there, It's super, super sturdy. Like, I honestly tried to pull this thing down onto myself, imagining I was a little kiddo. And when that thing is locked in, you can bang on it, you can jump on it, you can pull it in any direction, and it will not move. The only way to get that to collapse is to explicitly fold in the kickstand from behind. So it's still easy to disassemble. There's no nuts or cotter pins or anything, but it's secure when assembled. Really happy with that. I am now going to need to press in the bearing before we can finish development of all of the components. So I've got it set up on my press. I've got some spacers underneath so the bearing will end up centered in the plate because of course the bearing is a lot thicker than this plate. And I'm using an impact socket as a mandrel to push that in there. It's critical to always press a bearing in using the same race that has the interference fit. Otherwise your pressing forces are going through the races on the bearing and you'll destroy it. And you should really bolt down your arbor press, but I don't really have a good place to do that right now, and don't lecture me about it. So now I can finish test assembly here. The bearing pressed in beautifully, so that confirms our suspicions that we had nailed that dimension. This will be the first sort of all-up test of the mechanism, if you will. Get my axle bolted in place that we made last time. That goes in the bearing. I'm not going to bother with the snap ring because there's really nothing trying to pull the wheel out of position yet. But for now, we don't need it in there. And the pins are all close fits, so I can just slide them in there and they'll stay in there for testing. First official spin. Very, very nice. Boy, this thing's going to be fun. I'm going to need the rest of the pins in place to work on the pointer next. It's funny, that bearing is so good that just putting in those pins, the weight of those tiny little pins, is enough to cause the whole mechanism to swing downward as I add them. That's pretty funny. But now with all the pins in there, it's perfectly balanced, and my goodness, that will spin for days. I actually thought at this point I might need to add some drag to it because it spins for too long. Like, you don't want a raffle wheel to spin forever because, you know, people will get bored sitting there staring at it if it spins for 10 seconds, like the moment kind of passes for people. But as you'll see, that will definitely not be a problem in the final design. And you can see there where the snap ring will go and retain that in the bearing. All right, it's pointer time. Now, the first thing I needed to figure out was what kind of material to make it out of. I figured some kind of plastic, so I went into my plastics bin and I just held some different plastics up to it to see what felt and sounded kind of the best. Delrin was too loud and bangy, but ABS actually sounded really nice. It had kind of a soft feel to it and a muffled kind of sound. So I scored and snapped a little pointer out of some ABS and we'll give that a try. I haven't cut out the full shape yet. In software engineering, this is what we call an MVP, a minimum viable pointer. I made a little axle, once again with some offcuts of the hinges and a little bit of threading, and I'm thinking that should go in there like that. So I'm going to make a bushing that will hold that little pin in place at the top. I did a quick little sketch on a post-it note for what a bronze bushing might look like that could hold that in place. This is once again going to be the most over-engineered raffle wheel perhaps in history, with lubricated bronze bushings, but as you'll see, we'll dial this back a little bit in the end, but for now, I had grand visions of this mechanical pointer system. This is just basic 932 bearing bronze that I had on my shelf, and I'm turning a shouldered bushing that will sit in the metal plate at the back, hold the pointer at the correct distance in front of the wheel, and provide a thread on the back for me to bolt the whole assembly onto the back plate. So this needs to have a thread on the outside and a hole through the center of it, which if you watched my cold open, you know you got to be careful about doing that because the wall thickness can get too thin. You got to pay attention to the diameter of your bore compared to the minor diameter of the thread that you're cutting on the outside. It's easy for those to get closer together than you think. Then to hold it all in place, I grabbed a large piece of hex bar stock and I'm going to turn a big flat nut that will hold it all in place from the back. Making a nice big flat nut will eliminate the need for any kind of washers or other complex things. Again, just trying to minimize hardware, minimize component count in this whole assembly, while maintaining disassemblability, of course, because I could really reduce part count by just welding a lot of this stuff in place, but then I would be not able to take it apart, and it would be very, very difficult, probably impossible to powder coat if I did that. I suppose if you were painting, you could do more of just welding things together because it's easier to paint stuff that's assembled. If you don't care too much how good a job you do of painting, but I'm trying to do things a little bit nicer than that. And of course, always chamfer the corners on your hex nuts because chamfers are what separate us from the animals. Look how nice that is. Only takes a second and it really transforms any hex nut. With that whole pivoting assembly made, now I can go over to the back plate and drill the hole in it. I wasn't sure exactly how big that assembly was going to end up being, so I made it first. Centering up on the bearing, because it seems as good a reference as any for center line on this thing. Again, nothing too critical here precision-wise, but, you know, trying to make it nice. I've got it sticking way out in the vise like this because the bearing keeps it from sitting further in, and I can't flip it over because of the hinge pieces and, you know, yada yada. It's complicated, but this is the only position I could hold it in the vise. That, however, is an excellent fit. Very, very pleased with that. Now I can finally assemble everything and start working on the spring or the retention system for the pointer. This is going to be the trickiest part, and I knew it would be, but I didn't realize even how tricky. I started by finishing the sides of my MVP because we're ready now to do some real testing and I need it to be the correct shape so I can see how it behaves. It's clamped to the pin with one of those nuts that has the anti-slip feature on the bottom. There's little teeth on the underside of that flanged nut, so that will hopefully hold the pointer in place. My first thought for mechanism was to put a weight on the back so the pointer would just naturally swing down into place as the wheel turns. It seemed like the simplest option, and who knows, maybe it'll work. So I clamped a vice grip on there, gave it a spin, and very quickly learned a couple of things. One, the pointer will not stay in place very well unless it's extremely tight because that pivot is naturally wanting to loosen the nut, unfortunately. So not a great design there. You'd really need something like a key or something positive to retain that, but bear with me on this. So I tightened it down a lot better and gave it another try, but quickly learned that was way too much weight. So I put a much smaller weight on there and as you can see, weighting the pointer is not really the right approach. It bounces very strangely and it doesn't center very well and it tends to flip all the way around sometimes. It's not a nice motion. And because of the banging of the weight, it's very difficult to keep the pointer tight enough. You can see I had to tighten it so much that the axle was actually punching through it. I decided I'm going to need something stronger than plastic so I can clamp it tight enough. And so I tried some various metals. Brass was too loud and bangy, but aluminum actually sounded quite good. So let's try making another pointer out of aluminum. I got some thin stock and made another MVP. I actually made two of these because I also learned that the length of the pointer is very important. Where exactly on the pointer the pins hit it affects the motion of the pointer a lot. And if the pins aren't hitting it in just the right place, you won't get a good bounce. So once again, trying with a counterweight to see if I could make that work. But as you can see, even if the pointer is sturdy, it really doesn't behave well. But using my fingers now, this is kind of the action that I'm trying to get. I can create the effect I want by just putting some friction on the pin with my fingers. So it seems like some sort of spring-loaded mechanism might do the trick. So I thought maybe if I put an arm on the back and some springs on there, I can just put a little bit of tension on the pointer and get the effect I want. So to test this, I tack welded a lever onto that pin and experimented with springs. I thought one spring pulling straight down might be the simplest, so I tried that, but that really didn't work very well. So I also tried springs pulling sideways. You'd need one on each side so that you can spin the wheel both ways. But again, that just really didn't seem to work very well. It wasn't creating the action that I wanted. I also experimented with length a lot, as I said. It's really important that the pointer be easy to knock out of the way, otherwise it decelerates the wheel too much. But the problem here was the lever that I added was once again just adding a bunch of weight to the back. So I also learned the pointer has to be very lightweight and very well balanced, again, so that it's easy to knock out of the way, but it still has a strong return force to bring it back into place to stop the wheel. At the end of this video, I will summarize everything that I learned about designing mechanical raffle wheel pointers, but the TLDR is that A, it's a lot harder than you think it is, and B, it's a lot harder than you think it is. At this point, I had about a day and a half invested in trying to engineer this thing, and I had a deadline for this project. I had to get something that works. If you look at actual commercial raffle wheels, you'll see one thing that they all have in common. They don't use a mechanical pointer. They all have some sort of strip of plastic or rubber or semi-flexible material to act as the pointer. The only actual mechanical spring-loaded pointer that I could find is the actual Wheel of Fortune wheel. And fun fact, I used to work on the official Wheel of Fortune video game, and so I actually spent a fair bit of time on the set of the TV show and have had my hands on that wheel. And that wheel is extremely massive and extremely heavy, and all of that changes the physics of everything completely to the point where you have a lot more options than you have with a small desktop or tabletop wheel like we're building here. All of the smaller wheels and the lighter weight wheels all use some kind of flexible rubber, plastic pointer thingamajig. With the deadline fast approaching and no success in sight on that mechanical pointer, I decided it was time to explore more passive options. I went through my rubber bin and I found some strips of gasket sheet material, and that actually looks really good, like almost immediate success. I also tried spring steel. I have an old bandsaw blade, but that was much, much too stiff. So then I tried a thin piece of that same gasket material, and magic happened. All of a sudden, that's exactly the sound I want. That's the feel I want. That's about the runtime that I want. Everything just came together all of a sudden. The clouds parted, and Metallicor, the god of machining, handed down upon to me a rubber tablet, and I knew that this was the answer. That said, I did get far enough to know that this is possible to do. I just ran out of time on it. So if you want to build a mechanical pointer for a raffle wheel, let me tell you what I learned. First of all, the pointer has to be extremely lightweight, as I said. You don't realize how much that pointer will decelerate that wheel, and you don't want it to decelerate very much. I thought I was going to have the opposite problem, but it turns out no, deceleration actually is the problem. So the pointer has to be very lightweight. It has to be something fairly soft, otherwise it gets very, very loud, and that's unpleasant. You also need the right design for attaching the pointer to the axle. The pins hitting that pointer act like an impact wrench, and they will loosen any nut. Trust me, there is no amount of tightening you can do that'll keep that pointer from loosening. So you really need a key or some other form of positive mechanical retention. By comparison, the main wheel itself just has a single bolt in the middle, and that thing is several bananas in diameter, and it doesn't loosen at all because it doesn't have those impact forces on it. It makes all the difference. Impact wrenches exist for a reason, and they work super well for that same reason. In summary, I think the answer then is probably a plastic pointer that has a counterweight on the back that's not too heavy so that the pointer itself is perfectly balanced in mass. It can spin easily, but then has a little bit of spring tension on it, just very light, to make sure that it can decelerate the wheel the right speed and self-centers when the wheel stops. Somewhere in there is the answer. I couldn't quite get there in time, but I bet you can, so give it a try. My mission now, though, has pivoted to a rubber strip mounting system. So I've got my hinge pin from the pointer in the mill, and I'm going to cut a very long, thin slot in it to hold the rubber strip. This is such a thin slot that I wasn't going to be able to mill it out. An end mill that small wouldn't be long enough, so I chain drilled it out with some very careful center drilling along the top of that convex surface, and then that gave me just enough room. Well, actually, no, it did not give me just enough room to needle file in there, so I ended up having to bandsaw down the front of it and clear out the material a little bit with the bandsaw blade. My thought was, when I'm done with this, I'll just weld up that slot that I cut in the end, but actually I didn't end up needing to because the slot is thinner than the rubber strip, and the slot actually gives me a handy screwdriver slot to use to tighten this pin, so that all worked out pretty good. So the rubber strip slides in there, and then it's tightened down against the bushing, and that's what holds the rubber in place. And I'll put a nylock nut on this in the end as well because we're tightening against rubber here, so that nut isn't really going to get tight. It's not going to stay tight. But that is a massive success. That works perfectly. That is exactly what this design needed, and it's so simple, and it works perfectly, and it's never going to wear out. And my gosh, let's get this thing powder coated because I got to get it shipped. I wanted it to be kind of a fun color, and most of my powder coat is black, but I do have a couple of fun colors, and this baby blue is one of them. So I powder coated both sides of every piece one by one. I had explicitly designed each of these pieces to fit in my little powder coating oven because I knew I was going to want to do this in the end. I vastly prefer powder coating to painting. Here's the final part count aside from the metal base plates. I think I did fairly well. I'd be interested to hear from you if you think I could have reduced that part count even more. For powder coating the back plate, I put Captain tape around the interference fit where the bearing goes. Obviously, I had to press the bearing out again. Then powder coated it, pulled off the Captain tape, and then pressed the bearing back into place for the final time. I got away with only having to press that bearing in and out 3 times, which was good. If I do it too many times, it's going to wear out the interference fit, and that's not good. Now I can bolt on the hub that I made off camera, just a little brass hub that'll look a little nicer than the wobbly washers that you saw me using. This was a lot of powder coating to do, and let me tell you, it looked like something terrible happened to Smurf Village in my shop. I'm going to be finding blue powder for weeks. And I'm not going to say I definitely got Smurf powder in my coffee, but I'm not saying that. All of the mild steel parts that are left uncoated, I'm just hitting with some Bow Shield T9 to keep those from corroding. I don't want to powder coat those, of course, because they're moving parts. And I don't want to put oil on things and make this whole thing oily either. All right, final assembly time. Everything still goes back together nicely after powder coating. Always nice when that works out. It's finally time for the snap ring to go in because I won't need to take this apart anymore. And that goes right in place there. That worked out well. I do like snap rings. They're very satisfying. My original vision for this thing was that the wedges be dry erasable so that we could use this thing at all different kinds of fundraising events and we could change up what the prizes on the wheel are. So for that, I picked up some of this vinyl whiteboard contact paper. It's basically like whiteboard material on a roll. Comes in clear and white. And I used the white stuff. I tried the clear, didn't like it, switched to the white. I cut out wedges of it on my vinyl cutter to fit perfectly on the wheel. So I did a test with some regular printer paper to make sure I had the dimensions correct. Then I scaled that down and tested that. And then that worked out great. So then I cut it for real out of the vinyl on my vinyl cutter. If you're a regular viewer, you know I'm a recent fan of vinyl cutters. I picked one up for my locomotive project to do some lettering, and honestly, this thing is great. Like, I keep finding new uses for it. So if you think you might want a laser cutter, but you don't want to shell out what those things cost, check out vinyl cutters. They're awesome. And now suddenly I have whiteboard wedges on my spinning wheel. Very, very cool. Here goes nothing. Bust a deal, face the wheel. 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 Face the wheel. And survey says amputation. That sounds terrible. Luckily, this is a dry erase raffle wheel. So I'll just take that out of there, and puppy, hooray! I love puppies. I'm so happy to have won. Let's give that one more spin because I'm feeling lucky. You always spin one more time, right? You got to press your luck. And survey says bust a deal, face the wheel, face the wheel. Well, it's been nice knowing you. We had a good run here on YouTube. Thanks for your support, everyone. I'll let you know who my next of kin is to forward your congratulations on my passing. I hope you enjoyed this little raffle wheel side quest. I had a lot of fun making this thing, and the end result is super fun and super satisfying. And it was a massive, massive hit at the farmer's market where we used it for the first time. The kids loved it, the adults loved it, we gave away lots of fun stuff, and we're going to be using this thing a lot. Thank you very much for watching, and thanks so much to my patrons for making all of this content possible week after week, and I'll see you next time.